we had you install two programs. One is R and one is RStudio. And so you might have two icons on your desktop. R by itself will look like this. It's one single window. It's very almost reminiscent of like 80s computers. You know, for those of us that are that old, we're not going to work with R directly like this. We're going to work with RStudio. So if you have this icon on your desktop, feel free to just delete it. We're going to be working through RStudio. RStudio is called an integrated development environment. It basically packages R and lets you interact with R in much more easier way. So what we see on this console side here is R. So it's like R is inside one of the windows of RStudio. So R is one of the leading data science languages, also statistical software programming languages as well. You know, it's nice. I mean, it's free to download, which is why we're here, and it makes for very easy ability to share your research or share your work with other people. It is not better or worse than Python overall, which is kind of another complementary data science language. It's just different. It has its different strengths. So in RStudio, when you very, very first open it up, you're going to see 3 panes, right? This big pane on the left is the console, and this is where we'll interact with R itself. We can say, hey, give me 2 + 2, and it'll say, hey, look, it's 4. Well, I can do math. On the top right, you've got various other tabs, your environment, the history of commands, and some other tabs that we're not going to really get into. You feel free to play around with later. The environment is what we're mostly focused on right now. And in the bottom right, we see like a folder, like our files. So this is one way that we'll be able to access files, but also plots, packages. We'll talk about packages, and your help file. So if we're, Kathleen later will talk about how to get help. It's going to show up in this bottom right corner down here. So as you saw me do, when I interact with R, right now I'm interacting in the console. That command is sent off to R, it's executed, it returns an answer, and then that command's gone. If I want to run it again, I would have to retype it again. That's not very helpful for when you want to actually do multiple things in like a script. So if we go to the top left, there's either a plus button where you can choose an R script, or you go File, New File, R script. And that one will now pop up in the upper left. And so this 4-pane window is what you're most commonly going to see when you're interacting with RStudio, because for the most part, we're always going to be working through a script file in some way. You're distracting me. So any commands that you send through the console won't be saved when you shut down RStudio. But commands we write in scripts will save. There's one, and we'll be working in scripts in a little bit. There's one setting that I believe everyone should be able to turn on that kind of helps you retain your sanity when debugging scripts, because you're going to make an error. We're going to mess up. That is part of life. And one way to help you figure out and debug that problem is to be able to shut down RStudio and not keep anything in RStudio's memory, so to speak. So go to Tools, and then down to Global Options. And right in the middle, there's a workspace. Uncheck Restore R Data and say, don't ever ask me. And then apply and OK. This allows you, when you feel like you've just broken everything, you shut down RStudio, you reopen your script, and you're able to start fresh. And this is a good time to point out the learner notes, right? Everything that I've been showing you, the layout, the console, the setting, all of this is here. So if you like miss something right now, that's what these notes are for. Okay. So as I mentioned, there's two ways to interact with RStudio. We can type it in the console or paste it, type it into our command. So let's put, we already saw that R can be used as an overgrown calculator. So in our script file at the top, let's go ahead and just type 1 + 100. Now that's up in your script. To get it down into the console to actually execute and have R do that calculation, you could copy and paste it into the console. There's a run button in the top of your script file. And notice when you hover over it, it also shows you a shortcut, keyboard shortcut, Control-Enter. So if your cursor's on line 1, we got our line numbers off to the side, and I hit Control-Enter or Command-Enter for a Mac, it will do that copying for you into the console and execute it. And at the bottom, we can see our result of 101. So in the console down at the bottom, there is this little, we have our command 1 + 100. We have this, the output is right after it, 101. And then there's this, it's called a chevron, or it's like a greater than sign. That is our way of saying, hey, I'm waiting for you to tell me what to do next. So that's how you know it's waiting. Because we're going to see later how you know when it's stuck. Actually, we'll do it right now. So say we do 1 plus, and I forget to finish my sentence, and I run by hitting Control-Enter. It says 1 plus, and it's got a plus down here. It's like, okay, and what's next? R is waiting for you to finish the sentence. You can hit the escape. Once you click into the console, you can hit the escape key to get out of that. Be like, abort, sorry, I didn't mean that. Let me restart. So because R is a calculator, it follows the order of operations, right? So if I wanted to go 3 + 5 × 2, it's going to do 5 × 2 first and then add 3. So it follows all of the proper order of operations. It would be really bad if it did not. Now, something that sometimes, if you're sometimes messes with, I won't say math people, but people in mathematical fields, we often don't write the multiplication symbol between our parentheses and the number. And R has no idea what to do with that. Unexpected numeric constant. R's errors messages take a little while to get used to. Generally, the more you make the same mistake, the more you'll learn what R's error messages mean for that mistake. So when in doubt, just always put your explicitly talk about your multiplication. Explicitly use the multiplication operator. And same with exponents, you could, there's a shortcut, -4, not a shortcut. One way of specifying exponents is 2 asterisks. What I personally see more common is the caret, right? Caret is above the number 6. One last thing to note, not one last, but one helpful thing is in our script. So let's go to the top of our script and let's put a £. What is this section called? Wait, we just said like it's just using R as a calculator. That's what we're doing. We are using R as a calculator. There we go. I can spell. So in a R script file, a £sign or a hash sign makes a comment. That code is not executed by R. It will totally ignore it. But for readability, you should always comment your code to say, hey, this is what I'm doing. The other nice thing about working with R scripts and RStudio is if you have a £sign like this and I follow with 4 dashes, it helps create an automatic outline of your document. I pop that open in this little outline icon in the top right of the console. So this is a way for if you have a really long script of being able to find where you're doing certain things. So it's just similar to using headers in a Word document. Okay. So this was basic math, but there are mathematical functions that we're going to be wanting to use. Now, I'll just call it just like functions in general. So the first function that I want to talk about is getWD, or get working directory. So this returns what's called an absolute file path. And so on this computer, you're going to have a different file path than me, but on this computer, I am working under C, users, R Donatello documents. So I'm in my documents folder. So if I save anything or want to try to load in data, that's where it's going to be looking at. And we'll come back to how to change that and how to navigate that in a minute. But this open and close parenthesis is our functions. Functions take inputs such as sign of 1. So I'm passing 1 is called an argument. Anything inside of the parenthesis is called an argument. So say I want to round 10.1234 to 1 decimal place. It's going to return 10.1. So there's 2 arguments here. The first argument is the number I want to round. The second is how many decimal places. Now, how did I know that's what goes in each? Because I, at one point, looked at the help file for how to use different functions. So we're going to use functions a lot. But the take home is that it's the name of the function, and then it'll be surrounded by parentheses. We can also comparing things. So sometimes, actually go ahead and, after I spell that right, copy these from the notes, these 3 lines, either from the notes or you go ahead and type them in. And run them and just see what gets returned by R when you run these lines. And we'll use this as a test of the sticky note system. When you run these 3 lines, when you've got these into R and run these 3 lines, put up your green sticky or put up your green checkbox. Check mark in Zoom.
How would we run them?
So you can highlight all 3, or you can put your cursor after that line and click the run command, or Control Enter or Command Enter if you're on a Mac. So run is synonymous, running code is synonymous for executing code or submitting code. There's a couple of different verbs that we use. Okay, and so when you're done in person, either put your green sticky up. When you're done online, put your green check mark up. If you're having trouble or need some assistance, put a red sticky or red check mark up. We've got most people. Okay, so I'm going to run all 3 at once. We get a bunch of trues and falses, right? So what we've done is these are called logical comparisons or logical operators, I guess. And it's like, hey, is 1 equal to 1? Notice when we say if we want an equal, it's a 2 equal sign. You think of this as identical. Not equal is 1 not equal to 2? That's a true statement. Is 10 greater than 20? That is a false statement. So being able to specify, writing a comparison, a mathematical comparison, is it equal to, not equal to, greater than, less than? We'll be using that later. That's very useful for data manipulation, for like choosing specific rows, or identifying like certain criteria. So far, we have just been asking R to do math for us. So let's go ahead and take down your green stickies, and we'll clear the Zoom. And let's look at variables, variable assignment. So often we want to take a value or a result of a calculation and store it into a variable so we can do something with it later. And so we use what's called the assignment operator. And that's this arrow, this left-hand arrow. And that's the less than sign and then a dash. And this is saying take the value 2 and assign it to the variable x. Now, you'll hear me often say an object, and you might see that when you're like searching for R stuff online. Objects in R can be anything. X is an object. A data set will be an object. A plot can be an object. That's a really, really generic term for like almost anything that lives inside of R. So when I run this code, R doesn't print out at the bottom in the console. It doesn't do anything. Oh, okay, I can't say it didn't do anything. It didn't, huh? It did what I asked it to do. It took the value 2 and saved it as X. I didn't say, now repeat back to me, what did you just do? So it's doing exactly what I told it to do. How do I know it worked though? 2 ways. One, you can type the name of that object in the console and then it will print out. It's like, here is the value of X. Here is what is being held by X at this point. The other way is looking up in your environment in the top right corner. We see the value X and in the kind of the cell next to it 2. So that's one way to say, hey, one way to check is, did I do this thing right? Or did R do what I thought I was trying to tell it to do? So X exists and it is now carrying the value of 2. Now we can we can do stuff with that value X without actually referring to without knowing what value is in it. So I can take the log of X. I could do X plus 2. So it's like it's a math variable. It's why we call it variables, right? It holds a value. Now we can reassign it. So I can overwrite the value of X. And if you check in our environment, X now has a value of 100, not 2 anymore. And so when we start working on like multiple lines of in script files, R works from the top down. And so the value of X now is 100. It's no longer 2. So everything from line 27 down, if I'm using X, it will be the value 100, unless I overwrite it or overassign it. And you can overwrite your value by saying, hey, whatever X is, I'm going to add 1 to it. And that's on the right-hand side of that arrow. And then I'm assigning it overwriting X on the left. You get to name whatever it is on the left-hand side. So we're just calling it X right now. Now, this is important to remember because if I run line 28, X now has a value of 101. Because I took X, I added 1, and I saved it back into X. what do you think is going to happen if I run line 28 again? What's the value of x going to be? It's 101 right now. If I run this again, it's going to be 102. Yep. And I can test that by running it again and seeing in my environment, it's now 102. So this is a spot that inevitably trips up new users, is when you're modifying a variable and you save it back into it itself. And you're like, I don't know if that worked. And so you try to rerun the code and it gives you an error because X isn't what it was before you ran that code. So I mentioned that you get to name variables. You have control over it. Anything that's on the left-hand side of the assignment operator, that arrow, you get to name. Of course, there's rules there's always naming rules. Let's see, can we get the rules copied over real quick to the learner notes? Excellent. Okay, so can't contain numbers, can't start with a number, can't have special characters in it. I'm not going to go through like all the details. It's here in your notes. All I'm going to say is that once you kind of land on a style that works for you, like camel case or underscores or periods, it just might be helpful to be consistent so that you remember. And it helps for readability of your code. It does not matter. You could have very, very short names, X, A, DF1, DF2, or my variable for this data set. I mean, it can be relatively large. One of the things that we'll see with RStudio is there's a tab complete, so you don't have to type everything. But R is case sensitive as well. Okay, so first challenge. So go to the learner notes. And, oh. Yep, go ahead and paste. Where'd it go? Beautiful. Okay, so after all four statements are run, what is the value of mass and what's the value of age? So go ahead and test this out on your own. I'd say check with a neighbor, but if Rowan, you don't have a neighbor, you're all by yourself over there. That's okay. And then we'll check again, green sticky when you're done, when you have an idea. In Zoom, you're welcome to put your answer in the chat, but definitely put up your green check mark when you think you know the answer to what's the value of age and the value of mass after all these four statements are run. Okay. Seeing some answers in Zoom. Awesome. Okay. Are you good? Are you stuck? You got it? So in the notes, right? Here's this challenge. So this is the code that you're going to use. After all 4 of these are run, what is the value of mass and what's the value of age? Yeah. I think there's only about like 10 people who said they were going to be in person. I just like this room. What did you guys get? Do you agree, Raquel? Do you agree? Awesome. Yep, and that is my just repeating the commands. Yep, so let's copy code and we'll put it into R. So this is challenge 1. If I run all 4, remember, nothing shows up at the bottom. R is not telling me an answer, so I didn't ask it to tell me an answer. I just said, hey, assign mass to this number, assign age, and now do this calculation on mass and do this calculation on age. If I want to see the results, I can see up in the upper right, or I can type the name of the object that I want to see in the console. Yep, exactly, Maribel. Thank you. Cool. Okay. Now, you got that. Second challenge is write a command that to compare mass to age. I mean, we can see with our eyes. We can do the comparison in our heads. But pretend you didn't know what values mass and age were. Write a command to compare the value of mass to the value of age, so that you could answer the question, is the value of mass larger than the value of age? What we got? Still working? Yeah? True. Yep, so we go back to our comparison statements. And we said, what did we wanted if age was greater than mass or mass was greater than age?
Mass greater than.
Then you know what? I'm just going to flip this thing. Awesome. So like, and this is kind of like where the background computations of R are going to be helpful. It's like you've done other work, you have no idea at this point what the value of age and mass actually is, but you just need to know if one's bigger than the other. I don't care what the values are. Great. Totally.
So before we can do the comparison, the only reason why it's able to do the comparison is because we define the method.
Correct. The only reason line 37 works and that we can make this comparison is because mass and age have been defined. Exactly. And so this is one of the places to get make small mistakes because R is case sensitive. I've defined mass lowercase, but if I type age less than mass, I get this object mass not found. Object not found is like your #1 error message. And first things you check is did I typo it? Did I misspell it? Is that 90% of the time? Either I misspelled it or I forgot to define it because I was writing a bunch of code and I never ran the stuff before. You know, it's like, oh yes, I'm gonna define this, I'm gonna do all this, and then I just go and run line 37. Absolutely common mistake. Great question. So at this point, we have like 3 things in our working environment. We've got age, mass, and X. Sometimes as you're working, that environment could fill up real fast. And then it's like, oh, I didn't mean this for to be lowercase mass. I really did want this to be uppercase mass. And so I fix it in my code and all looks fine, except I still have lowercase mass sitting around in my environment. So sometimes we want to get rid of things, rid of objects for a whole variety of reasons. So let's see how to manage our environment. The function ls is like it's like a list. It's saying, hey, tell me every object that's in the environment. Now we can see that with our eyeballs, but remember, we're also learning how to have R do things programmatically without us having to see them. So ls will print out all objects in the environment. If I want to remove a specific object, let's say remove X. Actually, that's not in a quote. RM is the remove command. So now we can see in our environment, X no longer exists. But that's going to be a lot of work to remove every single object all at once. So we could remove, we want the whole list of ls. So ls, the function ls creates a list of all the objects in our environment. We can pass the output of that into the remove function without ever actually knowing what's in that list. And now my environment is lovely empty. What? The other way, I'm just going to run this so that I have things in my environment. There's a broom in the top of your environments tab that says clear objects from the workspace. Since we're working in RStudio, more than likely, we're working in RStudio interactively, like we have it open and we're typing in it. Clicking the broom is perfectly fine. You don't have to write code to remove object, to clear your whole workspace. We're good. Everyone, you're back. Oh, yeah, put your red sticky. Never mind. Green is when you're good. Red is for question. It's okay. Well, let's find out. Do you have to write list? Let's put a bunch of stuff in our environment. And let's just try this. And R says no. Error in RMLS must contain names or a character string. So this, and we'll see this again later with how to get help. the remove function, the first argument is not the things we want to, it's either a single object or a string of objects. So we need to have this list here. Okay. So LS, RM, sine, those are, I mentioned those are examples of functions. When you download R by itself, or like what we just did today, you're going to get the basic functions, right? Or it's a lot of them, pretty functional, but there are tens of thousands of packages, user contributed packages. So R is a free open source software. That means people out there, one of our couple of my undergrads have written packages that create functions to do specific things that like you could go out there and install. So anyone can write a package. A package is just a collection of functions that someone has created. And sometimes these functions provide shortcuts. So instead of writing 15 lines of code, when all you're changing is like one argument, they've packed that all together into a little function where all you put in is that one argument. Raquel and I have worked on writing functions for the Center for Gen Ag. I mean, you guys run the same analysis over and over and over, and all we pass in is a different variable, maybe a different data set. And so to keep it standardized across all data, across all variables, we created a function. So Jane, I think tomorrow we'll get into how to make your own functions. But for now, we're going to see how to install packages that contain functions that do super cool things. So right now, you could, to check, again, RStudio is lovely. When you start typing, it's like, it pops up this little autocomplete. It's like, do you want installed packages or do you want installed packages? It tell it which one do you want? If the function installed packages, like it's past tense, this lists out every package you currently have installed. I almost never use this one, but that's okay. I don't need to see this massive. There are functions, there are reasons for it, but this is how we see all of the packages that are installed. You can update packages, like if they're being actively developed, they might be released pretty regularly. You want to update it. The learner notes will have a variety of functions. The ones that I care about to see all packages is we want to install a package to get a new package. So let's, in quote, ggplot2. Let's install the ggplot2 package. So notice in prior functions, the argument we're passing does not have a quote, but here it does. Sometimes, especially when dealing with like words, like ggplot2 is not an object in our environment. It's a word, it's a name of a package, so it's going to have to be quoted. And then you'll see all of this scary red text. And it goes and it goes and it goes. And it looks like it installs a whole bunch of packages. So R is like this, I would say it's kind of like an ecosystem. The ggplot2 package is going to be, we're going to use it tomorrow to make some pretty fancy plots. It requires other packages that you may not have installed. So when you install ggplot2, it goes out and gets all the other packages that you need as well. So that's why you're seeing color space and glue and GTIL, like all of these things, they're all in the background. But we see that chevron at the bottom saying, okay, now R is wait. It is done with all of its downloading and installing. It's now waiting for me. I can interact with it again. So throughout this course, we'll have a challenge in a second for you to install a couple other packages. But installing packages, a lot of times like, hey, I want a function that does this thing. And you go on Google and you go and you find this person wrote this package that do the thing exactly what you want. This is how you install it. And they're all really small, so don't worry about like clogging up your computer with installed packages. Now, this installs the package onto your computer. It doesn't make it available. You don't get to use the functions inside ggplot2 until you load it. So loading, hey, Juan or Kathleen. Loading a package, we use the function library. That's like turning it on. You only install packages once for when you install R. Every time you install or update R entirely, you'll have to install the packages. If you have to reinstall packages. Yes. I find that nice and helpful sometimes because I install so many packages just trying things out. I don't always want all of them, and I'm not going to remember personally to uninstall. Yeah. And so when I update R, which I update R the beginning of every semester, if I wasn't teaching, I probably wouldn't do it maybe every 6 months. I would probably only update R every 6 months. They release versions quarterly. But to access the functions inside ggplot, you have to load the library, and that's something that we'll have to do at the beginning of every script file. And we'll use ggplot2 tomorrow. Yes. To work on it, yes, you have to load it. But installing it, I have it here in my script file, but in general, we don't want to keep the code for installing packages in our script file because every time we run the script, we would be reinstalling it, right? So you're welcome to comment that out so it doesn't get run again, or you type in your console, because I don't need to save this code. So install packages, plyr is another one we're going to be using. You can type it directly in the console and it will install it and it doesn't save that code. Okay, so next challenge, challenge 4, is going and installing more packages. So you can install the, well, you already have ggplot2 installed. Install plyr and gapminder. And then green, let me clear out the feedback. Green sticky when you have these installed. There we go. So again, we're green check mark once you install ggplot2, the plyr, P-L-Y-R, and Gapminder packages. Because we'll be using the data from the Gapminder package in a little bit. Hmm?
I did, but I didn't do it.
You made it mad. For the Zoom participants, if you need some support, we have a breakout room. That's a great question, Miranda. You can run a separate install packages for each one, but you can also pass a what's called basically like a list of all three of them to do all three at the same time. There is a way to do it with library, but not exactly like this. Yeah. Yep. Yes, exactly. Alan, you should have the newest version of RStudio. The newest version. All of the code that we're going through will work on the like a version of R and RStudio that has been updated in the past like year or so. For the most part, you might get some complaints when you install a package saying, oh, this package was built for R version 4.4.2 and you're running 3. Yeah, well, it still might install anyhow, though. It might just, well, and this is where there's a difference between an error and a warning, right? And so that may have given you a warning. So actually, if we look at my messages here, it said, warning, RTools is required but not installed. Fine, I don't need RTools. It's just letting me know that if I wanted to build a package, which I'm not, I need RTools. Warnings are, R will still do what you're asking it to do, but there may be limitations. There may be like some conflicts. Exactly. Package ggplot2 was built under R version 4.4.2. If you're running a really old version of R like 3, you may have some conflicts. But that's different than an actual error. An error, like what we saw, if I tried to remove lowercase mass again, when it doesn't exist in my working directory, object mass not found. That is straight. Okay, it says a warning message. It's not doing anything because mass is not found. So you insert plier, but scrolling stopped and you do not. So the downloaded packages, that's like sometimes it takes a while to download and install. this will be your sort of like end message before the caret. So it may take a few minutes. It shouldn't take a few minutes, but should. If it's completely stuck, you might have to restart RStudio. Okay. We're looking just for heads up. For a time check, we're looking at doing a break a little bit after 10:30. So that's kind of where we're at. So far, so we've got into RStudio. We've been seeing how to use R as writing a script, writing lines, writing code, submitting code, installing packages. The last piece I want to cover this morning